there. I am working on the factoring binomials and mixed review homework. And number 21 actually is the longest problem of this particular worksheet because there's quite a lot to do and consider. So I need to think about, I want to identify all polynomials below that are prime. So remember, prime polynomials, there will be no GCF. There will be no difference of squares. For my binomials, and the trinomials will not factor. So those three things are going to happen for it to be prime. So if I look at x squared minus 49, there is no GCF, but it is a difference of squares. I have 1 and 49. Those are both perfect square coefficients. It's subtraction and an even exponent. So this is not prime. I could factor that further using the difference of squares. Looking at 5a minus 18b, well, I have a binomial, so I want to look for a GCF first. Well, I've got 5 and 18. 5 is a prime number. It doesn't go into 18, so that's not going to work. And a and b are different variables, so I can't remove a variable either. There's no GCF here. It's also, I'll just go through the motions, difference of squares. I don't have perfect square coefficients, so this actually is a prime polynomial. Let's look here at y squared minus 2y plus 10. I need to think about whether or not I can actually factor this trinomial. I know there's no GCF. I've got a leading coefficient of 1. So if I were to just think about my x, I've got a 1 times 10 here in the bottom. I've got a negative 2 in the top. Are there two numbers that can then add? Let's look at my factors of 10. 1 times 10. There's no way I'm getting to negative 2. 2 times 5. No way I'm getting to negative 2, right? Even if I had negative 2 times negative 5, that would be negative 7. 2 times 5 would get 7. 1 times 10 would get 11. And negative 1 plus negative 10 would, nothing's going to work. So this is looking good, but it's prime. So prime could not be factored. This next one does not have a GCF either because 2 does not go into 5. I have another trinomial that I need to think, can I factor that? Can I find these two pieces? Well, 2 times negative 12 is negative 24, and I can have a negative 5 as my b. So let's think about my factors of 24. I've got 1 times 24, I've got 2 times 12, I got 3 times 8. I'm going to stop here. I know that if I did negative 8 and a positive 3, I'd multiply to negative 24 and add to negative 5. This process alone tells me that this can be factored. It's not prime. When I look at 3m squared minus 3, I'm looking for a GCF, and I can remove 3 from both of these. This is not prime. My last binomial, no GCF, right? There's nothing bigger than 1 that can be removed. And I've got addition, so it's not a difference of squares. So this is prime. And that is how you would go about doing this problem and checking each piece. Don't just assume, really go through, can these three things be done? If none of them can be, you've got a prime polynomial. Thanks.